Hello everyone, we're going to continue solving three variable systems, but I'm going to kind of make a little extension here and we'll call this polynomial curve fitting. Before I get to that, let's just practice solving a system, make sure we kind of remember how to do all this, and then we'll use the system to maybe answer a question that's kind of interesting. So when you solve a system, I'm very organized. I like to label my lines 1, 2, and 3. And remember, the first goal is to eliminate the same variable in two different ways. So if I see like those are two y's and then maybe I could pretty easy mess with those, I'm going to get rid of y. It doesn't matter which one you get rid of, but you have to just pick, like it's set up for x, but I'm going to have to mess with both later, so I'm going to do y. I'm going to take line 1, which is 2x plus 2y minus z equals -1. And then I'm going to double line 3. That way that's a 2. So 2 times line 3 will be 6x minus 2y plus 8z equals 2 times 3 is 6. Okay. Now I will get rid of y. Goes away. Nice. 8x plus 7z equals 5. And I'll call that my A equation. And I'll come back to that when I get a B equation. So I need to get rid of y again. I did 1 and 3 this time. I'll do 2 and 3 this time. Or I did 1 and 3 the first time. I'll do 2 and 3. So 2, negative 2x plus 2y plus 3z equals -1. And again, I'm going to double line 3, so that'll actually be the same. 6x minus 2y plus 8z equals 6. That's still 2 times line 3. So y goes away, great. 6 minus 2 is 4x plus 11z equals 5. I'll call that line B. If you notice, we now have two equations with two unknowns. We have no y and we have no y. We can do that, okay? We got to combine these two. Let's see, 4 goes into 8. I'm going to make, I want that to be -8, so that cancels out with this. So I'm going to multiply line B times 2. So this will be now -8x minus 22z equals -10, and I'll keep line A the same right here. 8x plus 7z equals 5. This cancels out. You have -15z equals -10 and 5. Was I supposed to double? Okay, -10 and 5, fine. So that will be just 5. All right, so I'm going to get a fraction. That's okay. We can get fractions. But it is -5, so let's make that -5. So now when I divide, I get divide by -15, divide by -15, so z equals 1/3. All right, so kind of messy, but that's okay. Not too bad. Once you have z, we're going to go back up here and get x. So I'll plug that into, doesn't really matter which one I plug it into. 8x plus 7 times 1/3 equals 5. 8x plus 7/3 equals, I'm going to write this as 5 over 1. And if you're trying to subtract 7/3 from 5 over 1, you need to make this a common denominator. So we'll multiply the top and bottom by 3. 5 whole is 15/3. So 15 minus 7 is 8/3. 8x equals 8/3. And now when we divide both sides by 8, that's the same as multiplying by 1/8. Those cancel out and you get x equals 1/3 as well. So far we have two fractions and they're both 1/3. And now we just need to get the last one. So we'll go back and get y. Which one looks easy? Probably this guy. So I'm going to copy it so I don't have to keep flipping back. Okay. All right. So 3 times x, 3 times 1/3 minus y plus 4 times z, which is also 1/3, equals 3. At least that's nice. 3 times 1/3 is 1 minus y plus 4/3 equals 3. That's a 3. Subtract 1, negative y plus 4/3 equals 2. And let's see. I'm going to subtract 4/3 on both sides. So again, 2 over 1 minus 4 over 3, you have to triple this. So 6/3 minus 4/3 is 2/3. Negative y equals 2/3. So positive y will equal negative 2/3. So kind of messy, 1/3, negative 2/3, positive 1/3, but that is now my ordered triple. Pausing. But shouldn't be that big a deal. We can handle fractions. We're going to have to keep doing more fractions to get better at them. But once you get your order triple, 1/3, negative 2/3, positive 1/3. Great. Okay. That's just a 3-variable system. There's no like thinking going on here. Let's do some curve fitting. So when I say curve fitting, what I mean is I have 3 ordered pairs, 1, 2, 3. And I'll show you the picture because maybe it'll be a little bit easier. So here's the ordered pairs, 1, negative 2, negative 2, 7, negative 5, 2, right here. I think that we can create a parabola that will perfectly hit all 3 of these points. And that's what we're going to try and do. And that's what this says right here. There are 3 ordered pairs. So if we have 3 points, 2 plus 1 points, we need degree 2. So we need a quadratic. We're going to write a quadratic that will pass through all 3 of those points. The first thing we're going to do is substitute in x and y into this formula. So it's y equals ax squared plus bx plus c. That's the standard form of a parabola. And I need to do it all 3 times. So first I'll say negative 2 equals a times x is 1 squared plus b times x is still 1 and then c. So the equation I create is negative 2 equals 1 squared is 1, 1a plus b plus c. There's the first one. Let's do the same thing with the second ordered pair. So I'm doing the same thing here. I'm plugging in y is 7 and x is negative 2. So wherever I see an x, I'll put a negative 2. And then I'll simplify that. Negative 2 squared is 4a minus 2b plus c. And then one more time, if I plug it in here, negative 2 equals a times negative 5 squared plus b times negative 5 plus c. So negative 2 equals 25a minus 5b plus c. What we have done is create a system of equations that when we solve, we will get the a, b, and c coefficients for the parabola that we need that hits those 3 points. So I'll write my lines. I'm going to actually move this to the other side, a plus b. I'm just going to rewrite it with the single term on the right. Line 2, 4a minus 2b plus c equals 7. And then the last one, 25a minus 5b plus c equals negative 2. So we have a system of equations, and we need to get rid of a variable. Probably the easiest thing, since those are all 1c, I'm going to get rid of c 2 different ways. And I think I'll just do like 1 and 3 and then 2 and 3. So let's do line 1 and line 2. I'm actually going to make these negative. I want all those to be opposites. So I'm going to multiply negative 1 times line 1. Minus a minus b minus c equals positive 2. So flip all those, and I'll leave line 2 alone. 4a minus 2b plus c equals 7. So to get my a equation, that goes away. I have 3a minus 3b equals 9. I'll call that my a equation. To get my b equation, I need to eliminate c again. And like I said, I'll just do lines, I'll do 1 and 3 this time again. And I'm going to just make negative, I'll do the same thing I just did. Minus a, minus b, minus c equals 2. And line 3, 25a minus 5b plus c equals negative 2. Okay. So now c goes away. 24a minus 6b equals 0. 2 plus negative 2 is 0, so that's my b equation. Now, it doesn't matter what variable I get rid of from here, but I have two variable systems. I have a and b, and I have a and b. It looks like 3 and negative 6. I'll make this a positive 6. So I'm going to multiply line a by negative 2. Negative 6a plus 6b equals negative 18, and line b, 24a minus 6b equals 0. That's okay. 0 is just a number. 24 minus 6 is 18a. That goes away, equals negative 18. Hey, a is negative 1. All right, we're in the game. Now, we'll go back up, and we'll say 3 times negative 1. So I'm plugging in right here. That's negative 3 minus 3b equals 9. Add 3 to both sides. Negative 3b equals 12. So when you divide both sides by negative 3, you get b equals negative 4. We're close. Now we just need to get c. I'll pick the first one, a plus b plus c equals negative 2, and I'll just plug in a is negative 1, b is negative 4. I don't know c yet. Negative 5 plus c equals negative 2, and when I add 5 to both sides, I get c equals 3. So my order triple, negative 1, negative 4, positive 3. But what we actually found are the coefficients for a quadratic, ax squared plus bx plus c. So if I plug in a is negative 1, and b is negative 4, and c is positive 3, this should be the equation that hits all three of those ordered pairs. Let's hope I did it right. Negative x squared minus 4x plus 3. So I'll come down here, negative x squared, and then it's minus 4x. Pretty close. Plus 3. Let's go. See how it hits all three? Right there. 1, 2, 3. Got him. Okay? So we created a system of equations, and then we solved that system of equations. And by solving that system of equations, we found the coefficients that will hit those three ordered pairs. So that's pretty cool. And if you are able to do this, I'm going to give you guys some bonus points because this is a pretty cool extension. So try the practice problems and make sure you smash that like and subscribe button.